Hello and welcome back to the Ghost Island tutorial. As you can see, I've actually opened up my Unity today. Beforehand, if you haven't, you click on Unity Hub and then you click on the project name. Okay, right. So in the previous part, we were discussing how we can see different values in print to console and the difference between update and start function. Okay, so hopefully you guys have a good understanding of that. The update function runs per frame, and that can be anywhere between, at least in my case, it was anywhere between 10 to 15 times. What we're going to mainly focus on in today's in this part, that is we will be working on the movement script. That is, we're going to be making sure we can make our player, that is the circular object, move around the world. Okay, and this will also allow us to see how the update sometimes, how we need to take into consideration how we are working per frame. Okay, I'm just going to see if I'm live. Yep, that's all good. So okay, so go ahead, from the assets section, click on your scripts folder and then click on the movement, double click that is, and it will open up the editor, no matter which editor you're using. I personally like Visual Studio because I started using Visual Studio from maybe when I was in year 11 or so it's like a personal preference. Now this was the code in part 1, which was kind of relevant to what we were doing. It's just it was just for us to see how start differ from update. Okay, so what I'm going to go ahead and do now is I'm going to get rid of the previous codes. A quick note for anyone who hasn't watched part 1 and just starting with this video is not for someone who is working on a project or have an assignment due and stuff. This is about learning C# from the very scratch, and also learning to use Unity. Okay, so if you're in a rush and you want some quick fix about some sort of problems, maybe you're moving an object using rigid body, or maybe you're simulating gravity using physics, not using physics, Unity Engine's physics, this video is not for you guys. Okay, it's just for anyone who is just into coding for the very first time. Right, so as this is going to be our proper first part where we talk about scripts, what I'm going to do is I'm going to go ahead and delete the entire thing. If you guys have copied that, I mean, I didn't really link the code in the previous part because I didn't really want you guys to have this, because there's no point. What I'm going to do is I'm going to just get rid of all of this. Alright, so what I want you guys to do now is to also get rid of whatever you have inside from this opening curly brace. Okay, so after mono behavior, this opening curly brace to this line 24's closing curly brace, whatever we have in between, I'm just going to get rid of them. Okay, there you go. I haven't talked about this using Unity Engine, system collections. Don't really need them at the moment as well, but I'm just going to keep it like that, okay, because I don't want you guys to worry about them. It's just going to complicate things for unnecessarily. Okay, so this is where you basically start scripting. Okay, the first thing we want to know is, if we go back to Unity, is the objective of the script is to move the player. Okay, so if I click on this move tool, the top left, and then go back to the scene, you can see how I can move my player, and we change its X position, Y position when it's moving left and right. It's a 2D game, we're not really focusing on the Z axis. And before we get into that, we need to know how codes are typed in C#. So C# follows something like a convention called Pascal Casing. Okay, now wherever you see codes, and if you see codes before, if you see anything before and preceded by these double slashes, that's a comment. Okay, so that those are not codes; those are English comments to explain what the codes are. I'm going to be using comments heavily, so it's important for you guys to know that how comments look. So C# uses Pascal Casing. Okay, which is a way for you to type codes. You'd see most so mono behavior, you can't have spaces in C#. Okay, so what you have to do is you have to start with every every letter would start with a capital letter. Okay, every word starts with a capital letter. Okay, and every new word would also start with a capital letter. Okay, on a behavior. So that's like an example here. So that's what Pascal casing is. Okay, so if you were saying something like I am hungry in English, okay, Pascal casing equivalent would be I am hungry. Okay, like that. Just an example. Obviously these are not codes, and whenever you have double slashes preceding anything, that's English comments for you to understand. Another way is to code a comment as well. That's slash double star, well triple star, and that. Okay, and this allows you to like have sentences or like paragraphs of comments explaining a lot of comments. Okay, so I'm going to be using this as well to explain what I'm doing in certain cases. Okay, so Pascal casing is what we use to type codes. There are more to Pascal casing than just this. I'll cover them as we go. Okay, so I don't want you to take in more information than you need at the moment. So the following code will check for inputs. Okay, so this is how I'm going to go about this lesson. I'm going to first check for inputs. So it's going to be like key pressed events. All right. Yeah, following code will check for inputs, key pressed events. So how you do that is I will just bring back the update that I deleted. So what you do is you just type a void. To be more specific, to be more correct, you just want to start off with private. Okay, and Visual Studio uses predictive texting, so it will bring this up, private, void, and then update. Now when that kind of did it by itself. I don't want that. I actually want to do one by one. So round brackets like that. So private, void, update, round brackets, and we're going to go to line 15 and then have the curly braces. Okay, like that. Now this again is a part of C#'s Pascal casing. A lot of programmers you'd see have the curly braces over there and then the second curly brace down there. Okay, it's just personal preference. As I started off with Java, I kind of liked this and I used to code like this, but now as I've been coding with C# for quite some time, I use this convention as well. Okay, so what this is, what exactly is that you're looking at? Well, this is what we call a method, a function. Okay, a function would start off with, this is what we call access modifier. Okay, so private, and then void is kind of like a return type, and then the name. Okay, I'm just going to quickly do that here. So syntax for this function is like this. So you have access modifier going in first, then return type. I'm going to explain them as well, so don't worry about them. Return type, and then name, followed by the two round brackets, and then the scope. So how far will the code be covered? Okay, so you'll have the scope starting with curly brace and opening curly brace and closing curly brace. Now, what is an access modifier? An access modifier is really something that gives access to this function, okay, outside this script. What I mean by that is, so I'm just going to type the access modifiers up. So we have private, we have public, we have protected. So there are these sort of primary access modifiers. So whenever you use private, okay, this method, if you go back to your project, okay, so take a scenario, for example, where you're working in a team, okay, you're working on a player movement, and your friend may be working on player attack, and for some reason they need, a good example would be the person who's working on the attack needs to know which direction the player is facing. Okay, so they need access to the player movement script. But as you're working on the movement and your friend is working on the attack, you don't necessarily want your friend to change your script. So what you do is you just make the code public, the ones that you want your friend to have access to, and the others to be private. So they don't have the ability to change that particular code. Okay, so that's what an access modifier is. An update event by default is private. Okay, Return type would be the next thing. Return type is nothing but what it returns. Okay, so think of functions as like an oven. Okay, so you put in ingredients, then you put it in a pan, and then put it in an oven, and then you get a cake. Okay, depending on how good a baker you are. I'm not a good baker. So return type is basically that. So you write all of your codes here. So like code. I can't even type code. Okay, so these are the codes, obviously. So you write a jumble up a lot of codes, and it gets executed. Then whatever you have here, the computer would be expecting this type of return, this type of value when the function finishes. Okay, void means it's not going to return anything at all. All right. I'll talk a lot more about return types when we get to that. Name is that nothing to it. You can name the functions anything you want. However, update, as I showed you in the previous part, is a built-in function, a built-in event, and you have to match this particular name. Okay, so that's what you have: private void update, and this is the scope. Any code you write outside would not be considered in an update function, update code, so it would be executed outside update. But I want the update to check for my key inputs, because you don't know when the person may be pressing the key, and we saw already how the update works every frame. Okay, so no matter when the person presses whenever your user presses a key, your script will be able to pick up on that. Okay. Now, to use to detect update, detect key input, what you need to do is use this C# class called inputs. So input, okay, dot get. You can use get access. Okay, that's one code you can use. You can also use get button down. Okay. Get button up, get button down. So these are the methods you can use. Okay, these are built-in methods that you can use to detect inputs. Okay, so I'm just going to first use get button because it's easier to understand compared to get access. Okay, so input.get button, and then you have round brackets. Okay, so every time you are using a built-in function, okay, as functions they have the round brackets. Okay. They serve a lot of purpose. Sometimes they're taking values to do something here. They just want to take in values to check for the button name. Okay, as you can see, if I hover over it, it says string button name. So string is one of the return types or data types that you can have. Anytime you see string, you need to know that you need the quotation mark. So anytime you see any type that string, you just need to have in the quotation mark. So input.get button. Now what button do? You can't do WASD right away like that. Okay. There are ways to do that. I think there's something called pretty sure that's called input.key. Get key. Okay, so if you were using get key, you can use WASD like that, but there's an easier way. Okay, easier, more flexible way. That is, we want to use one line of code that would check for both my up key, W key, and however many keys you want to define. How you do that is we need to first go back to Unity. Then we want to go and click on the edit button. Okay, the top left, and then we go to project settings. Okay, so project settings down at the bottom. There you'd have your input manager. Okay, input manager there, and then you'd find your axis. Okay, here you can see how you have horizontal maps to your. You can see how it says negative button left, positive button right. So if you use horizontal, what it would do is it would just make sure that whenever you're pressing the left key or right key, so left key would allow act as a negative influence, right would be well, you know what, axis would just not make sense at the moment. I'm just going to work with what do you call it, buttons. Okay, so I'm just going to add another axis just so I have control over it. So it's going to make this, see where it says size 18, I'm going to make it 19. What it does is if you just press enter, 19, it creates a new button here, new axis, and I'm just gonna ignore horizontal for now. I'm gonna go to this one, the very bottom one, which we created actually. So if you do 18, do it back to 18, and you'd see the new cancel button gets removed. So I just created that 19, and now what you can do is just name whatever you want to name it. Now, just to keep everything simple and like consistent, I want to name everything with the capital letter. Okay, so every word would be a capital letter. So I'm just gonna call this one right. Okay, right key. Oopsies. And there are a lot of other ways to do inputs, especially axis. If I'd have used axis, it could have been just one line of code, but that, as this is a very beginner's lesson, I wanted you guys to have a full understanding rather than just type up one line of code, and it would have worked, but you would not have got the full picture. So just naming it right, and where it says positive button, I'm just going to use my right key. Okay, so I think that's called right, pretty sure. Horizontal, yeah, it says right. Okay, so I'm just gonna say where it says positive button, I'm just gonna type up right, and there's an alternative positive button. I'm just gonna get rid of the joystick button one because I'm not planning on making this a controller game. So this one I'm just gonna use D. Okay. Don't worry about the gravity, dead, or sensitivity. That really comes into play when we're using axes. Okay. Right. So my D and right would map to this name, right? So whenever we press either the right key or the D key, this button would get triggered. This is like a virtual button you're creating for yourself. Okay. And again, there are a lot of ways you could do this movement, and I personally do movement with one line using my axis if given in certain scenarios, but I wanted you guys to get a full picture. Okay, I think this is a better way to understand how they work. Right, so with that done, with this part done, make sure you have the right spell correctly. Okay, that's the name of the button and also the positive button and the alternate positive button. Okay. Once you're done with that, go back to Unity script and just type that name up, the virtual name that you created. So this right name maps to our keyboard's right arrow and D arrow. Okay. So this thing would be true. All right, and that's one of the other data types, return types. This would be true every time you press that key. Okay. Now, the reason I'm just coding like this is because I wanted to show you guys the semicolon. So every time you add a code like this in a statement in C# must terminate with a semicolon. Okay. Now, before getting my player to move, I want to quickly print this value out. Okay, for a couple of reasons. First, I want to show you guys how you can use something called a variable. Okay, a variable is a nice, neat way for you to store values. Think of player health, think of score. You want to store values. Okay, so we just want to quickly dive into this, not in detail, just an overview of sort. So I want to create a variable of type bool, that is Boolean. Boolean is a type that allows you to store true or false values. Okay, as I said, get button would trigger true whenever you press the right key. The right button. Right button is mapped to our right and D keys on our keyboards. So bool, and then the variable would have a name. So first you have the type, that is the bool types. The computer knows, okay, there's a bool variable going to get created, and I'm going to name it pressed, let's say. Okay. Okay, so the value you store is by using this equal sign. So you have input.getButton, so the computer would ask, or would on every frame it would just keep checking if a right key is pressed, and then if it is, this pressed would become true. Okay, so what I'm going to do is I'm going to go to line 26 and do a debug.log. So I want you guys to see the value, and this is something I would like for you guys to do as well. Just print out a value. Okay, so debug.log, hopefully you guys can see it's a function that prints to your console. Now I want to have a string, like quotations like this, I used it in the previous video, but obviously you might not have guessed it. It's like a string. I'm gonna just say is right key pressed space. So whatever you do here, they're not really so anything you write between quotation, they're treated as just words. Okay, so I just want to see a nice little separation before I actually add in the value. I want to have this text appear, and then the value of this pressed, whatever that may be. It may be true or false. To do that, I just need to be outside the quotation. I'm gonna have a space. You don't need to, but I like to have my codes nice and spaced, and then a plus. Okay, another space. So plus would allow you to join this sentence with this value. Okay, so pressed. Now again, this is not an actual part of the code. I'm just showing you guys what we're gonna do. So if I save my work and go back to Unity, it's gonna get rid of taking forever. It's gonna get rid of the input manager. Why is it taking forever? Okay, this one. Okay, so if I have my console up here, maybe. Okay, so you can see a better view of console. Just gonna drag it down. All right, so if I launch, you'd see it's false all the time. Okay, so it's false all the time. Like we aren't pressing. So what's going on here is it's checking if we have pressed, not if, I mean if it's checking whether the right button is pressed or not. Okay, so I'm gonna see and try and map if I can get it true at any point. So I've pressed a couple of them, couple of the buttons. See if I can map any of the true, which would be right about there. Wait, I missed it. There was one true somewhere. There you go. So that's the timestamp where I pressed true. Okay, the moment I released the key, it went, after a while it went back to being false. Okay, so the idea here is, so get button down, get button allows you to keep returning true as long as you hold the button down. If I keep holding it down, you'd see, pause now, you'd see how all the sort of last few frames had true because I held my button down. Okay, one of the functions that you can use is this one. You know what, I'm just going to have a quick timer code. Don't worry about this timer because I probably won't get what I'm doing. I'm going to quickly do a timer code so it prints every you know what, it actually helps if I do it every frame, so I'm just going to keep it to like this. Okay, so get button allows you to get the button holding down. Get button, there's another one called get button down, which would return true only once, okay, what the frame you press right. Now, whenever you're working for a continuous movement, you don't want get button down, you only want get button. Okay, so if you're holding down, your player moves. So this is the code that we're going to be using. So I'm just getting rid of the debug code. Now, what I'm going to do is I'm going to go to line 28 and have something called conditionals. Okay, conditional allows you to really move your actor. Oh, sorry, not move your fuck. Allows you to check for conditions. Oh my god. Okay. Before I do that though, I'm just going to quickly show you guys what the code we're going to be using to actually move my player. So if you remember, we have this transform component on every object. We're just going to use that. Okay, so transform with the small letter, transform.Translate. Okay, transform.Translate is the code you want to use whenever you want to move your player. Okay, that's whenever you want to move your player without taking physics into consideration. As you can see in my game, I actually didn't really take physics into consideration to keep things simple. There are other ways to move an object using the rigid bodies and other functions, but this is the easiest way to move. Okay, so transform.Translate, again, round brackets and semicolon. Now, translate allows you to move an object, okay, to a certain direction. The way you get a direction is by using vector3. Okay, so this is a class. So you go vector3 dot, you have some built-in directions. Okay, so you have right, you have left, okay, you have up. So I'm just going to use right for now. Okay, so you'd see how this code, line 27 that is, it becomes kind of irrelevant at the moment, because there's no way for us to check if we are pressing the right key or not and then acting on this. Okay, we're going to talk about that in a bit, but let's just run the code. Okay, so if I go back to my Unity, I'll bring my console down actually. All right, so let's start the game. I'm gonna move it a bit to the left because my player is gonna move really fast. Okay, so if I launch, you'd see how glitchy the movement is and how fast the player moves. Okay, see, there's a glitch as well, and that is, hopefully you guys can think, at least in a way, why that may be. That's because the update event works so fast that every second it maybe is running for 15 or 16 times in my computer. So it's moving vector right. It's nothing but a value which looks like kind of like this, 1 0 0. Okay, so 3 vectors, 3 directional array, 3 directions really. As it's facing right, it's 1. If you would have gone with left, it would have been -1. Okay, so it's adding 1 to the player's position. So if I go back to my Unity, so it's like it starts at 0, then 1 2 3 4 5 6. So by the end of a frame, by the end of a second, which may have 14 frames run, it may be at position 14, and therefore you see that glitchy sort of movement. And that's the problem when you're working with update. You need to make sure you are taking the frame into consideration. Okay, so what you do instead is, you obviously need the direction, vector right, but you want to scale it according to the frames at which your computer is running. Okay, so you want to multiply it. You go Shift and 8, that is the multiplication sign, and then you go Time.deltaTime. Okay, so this Time.deltaTime is nothing but the amount of time it took from the previous frame to the current frame, okay, which typically in my computer is 0.003 seconds. Okay, so just scaling it by that amount, which gives you this smooth. If I launch, oh wait, I didn't save, so it's not gonna work. I'm gonna go back. If I save, remember to save. Okay, if your code isn't working, and I can't tell you how many times this happened. So I do a code, right? I do a code, and I'm like expecting my code to work, and it doesn't work. I'm so frustrated. I'm just trying to debug, but it turns out I never saved. So anyway, so you'll see how it moves really gradually, rather than a sudden sort of stop and start movement. Okay. So this is how you basically take frames into consideration. So tip here, or point to note here, would be every time you're doing something on an updated event, it's really important that you take the frames into consideration using Time.deltaTime. Okay, so Time.deltaTime is nothing but so Time.deltaTime allows you to like, it's just a time passed between frames, okay, between 2 frames. So with that, we can actually introduce some speed as well. Okay, so this is kind of like a direction. Now you want to add some speed. You can add some speed. So see how we have added a boolean called pressed. We can add a speed as well, speed variable. So what you want to do is you want to go back up to, well, I have a lot of comments here, but obviously you guys don't. So what you want to do is just towards the top of the script, so just after the opening curly brace, maybe hit enter and create a speed variable. Now the speed variable obviously would have the name speed, but would need a type. Okay, so the type for me would be float. A float represents any sort of floating point numbers. Okay, so decimal point numbers. So if 10 is an integer, a whole number, float would be 10.0 or 10.5. Okay, so that's what a float is. The reason I'm making speed a floating point number, not an integer number. That is, it gives you more precision. It helps you out with having more control over your speed. Okay, so speed equals to, maybe I'm going to go with 10, maybe 5 f semicolon. Now, one thing we need to know, space double slashes. So every time you add a float variable, you must add f afterwards. Okay, by default, whenever you do float, Unity or C# kind of turns it into a double. Okay, I don't want to go into the details of doubles and floats right now. We want to use float, so it's just like you're forcing it to use a float. Okay, so every time you're using a float, make sure you add this f afterwards. Okay, just a way to tell the computer that, okay, this is a float value. So now that you have float, I want to multiply that here. Okay, so I have vector 3 right multiplied by the frame rate. Okay, space multiplied by my speed. If I save, not making that mistake again, so save. If I go back, and now you'd see how the character moves at a faster speed. Okay, is there any way I can move my player a bit to the left? Okay, this should give us a better view. So it makes the player move at a faster speed. The thing is though, as a programmer, you are happy with the way it is maybe, but as a designer, you may want to have access to the speed. Okay, so you don't want to go and mess around with the code. Rather, you just want to have a quick section here that may allow you to change the speed. Okay, so when you're playing the game, when you're testing the game, you may not like the speed. You want to speed it up or you slow it down. What you do is you go back to your script as a programmer, that is, and you add something. You can either make it, so there are two ways. You can either make it a public. Okay, so if we can make it a public, space float, right? If I save and go back, you'd see how now my Unity changes to show the difference. So you have the speed column here. You can make it 10, 100, or 5. You just go like this, that, to decrease and increase. Okay, so if I make the speed 1 here, no matter what you have the value here as default, that's just a default value, but when you press play, Unity would read from this particular box. Okay, so now my speed, although it's default 5, it's going to go at 1. I can increase it up to 5, 100, or 10. Okay, so that's what you can do as a design, as a programmer, so allowing your designers to work. Okay, so maybe you're working with a friend who's a designer and who's working in charge of your designing, and you're in charge of your coding. So you want them to, they're like, no, I don't want to do anything with the code. Just let me have access to all the things that I need access to. So that's how you do it. That's one way to do it. But if you don't want others to have a direct access, for example, going back to the example of movement and attacking, if you don't want other programmers to have access to your speed variable, okay, but you want your designer to have access to here. Okay, so if I just make it a private, hopefully you guys can see this tutorial is not for uni projects. Okay, it's for someone who wants to learn about it and who has like time to learn about it. It's not for if you have a deadline due or something. Okay, so if I launch, oops, I don't want to launch. If I save, you can see the speed box disappearing. That's because I've made it private and no one has an access. Like no one can access this particular field anymore in Unity. Okay, except this class really. So what you can do, you can have this as private, so no other programmer can have access to your code. Okay, but you want your designers to have an access. So what you do is just on top of the field declaration, you just go and have the round brackets, the square brackets, and I write up serialized field. Okay, serialized field. Okay, what this does is if I save my work, so serialized field between round brackets. If I save my work and go back and launch, not launch. Why am I launching? the serialized field brings this part back up. Okay, so it is there for the designer, but again, if you have multiple coders in your team and you don't want other programmers to have access to the speed because you figured out something that works well for you, and you don't want anyone who's working on maybe baddies or maybe working on a boss character to mess with your player speed, or any other variable for that matter, you want to make it private so no one can have access to the code, but the designer, by making the serialized field, would have access when they're designing and building the scene. Okay, so when they're playtesting, they can tweak it a bit. Alright, so that's a couple of ways to do this. One, you can use a public access modifier, allowing everyone to see it. One would be private. It really depends on what you're going for. I typically do this. So before like any project, you obviously sit down with your team and discuss how you're gonna go about your things and how the diagram looks, and then you decide on what you're gonna do. But for now, I just wanted you guys to know how they are. Still though, the code is way like long way away from being completed, because right now the character can move. Obviously, yeah, it has speed. We have some control over its movement, speed and everything. Okay, it can also make a negative value to go left and right. But we need control. We want to use this pressed variable to control. Okay. So what you do is, go one line below. What you're going to do is we're going to introduce something that I talked about earlier. Is conditionals. Okay. So if is something that you use to add in conditionals. You can use switch cases as well. Or we'll talk about. Maybe not in this video, but like yeah. So if is something you use to bring in conditionals, and you can see why we need conditionals. Right now, there's literally no control. We know that the right keys are not pressed. The D and the right arrow. We know that they're not being pressed. Okay, we literally printed that out earlier. But the thing is, this code is working all the time, every frame, so my character moves, and I want to have some control. So you introduce this if, which comes with this round bracket, and inside this round bracket you can actually check for the value. You can say, okay, if pressed equals, so two equal signs allows you to check for truth statements, so if they are true or not, okay, truth value rather, true or not. So if pressed equals space, I like to keep spaces, but you don't literally have to do space, you can just do this, but I like having spaces between. So if pressed equals to true, okay, as I said, bool represents true or false. So if press equals to true, okay, you want your code that is transform.Translate, and then the directional vector times by the frame rate, so Time.deltaTime times by whatever speed that is. Okay, you want that to translate your player's transform, meaning moving the player. Okay, so what you do is you go to next line, okay, and declare the scope of the if. So how many codes would go under this if? To do that, it's really easy. You just have the curly braces. Okay, that is kind of self-explanatory. Oh my god, oh my god, I just keep swearing for some reason. It's quite easy to see why we need the round brackets. I know the curly braces. I know in Python they work on indentation, which I kind of not a big fan. So I find this better in terms of representation and understanding how much code they're gonna be inside the braces. So we're gonna have the curly braces, and I'm gonna hit an enter. Just show it like nice and tidy. Right, so if the pressed is true, I'm just gonna highlight this code, the transform code, and drag it and place it between the braces. Okay, the indentation is quite off, so I'm just going to go to the start of the line and press a couple of 3 tabs. Okay, so my player will be moving whenever I press the right button. So if I go back and launch, you see my player is not moving at the start. It's only when I keep holding the button down, my player moves. I want to take this time to actually demonstrate the problem with obviously get button down works when let's say you're working a jump function or something. So if I do get button down, this returns through the frame you hold it down and not afterwards. Okay, so just the frame you hold it down and false afterwards, meaning even if you hold this button down, let me actually demonstrate. So even if you hold this button down, you have to like keep, wait, did I save and stuff? I didn't save it. Me and my saving. Okay, so didn't really save the function. Script, rather. Okay, so if I launch, you can see how I keep after releasing my key. So I have to release and then hold again. So if I hold it down, it's going to move once and never after. That's because get button down returns true the frame you press it, and false afterwards. So you can totally see when this becomes really useful. For example, you're doing a jumping function where you want your player, so you're doing a platformer game where you want your player to jump, but you don't want players to, like, users to spam your space button to jump. So you can just use get button down. So you have to keep pressing it. Right. So that's why I'm not going to use get button. And hopefully you guys are a bit a better understanding of how this works. Now, this line 31 on my screen is not required really. Okay, I just made this so you guys can have a better understanding. I'm just gonna get rid of this because it's just gonna make my code lengthier. Okay, so instead what I'm gonna do, I'm just gonna use this part here between the round brackets of if, because it's essentially the same thing. It's still gonna return true. Okay, so I can just literally come here between the ifs brackets and go input dot get button round brackets. We don't need a semicolon, by the way, because it's between the round brackets, and then the round bracket we have the quotation and right. So it'll still do the same thing. Okay, we'll still do the same thing. You can have space equal sign then true. So if this returns true, you make your player move right. One of the things that you might have noticed, if does not require a semicolon at the end, because that is kind of it's allowing you to check for conditions. Okay, every sort of statement goes between the curly braces, not so there's not really a statement, so you don't really need a semicolon there. So if I save my work and go back, you'd see it still does the exact same thing, without us having to like have a really big have 2 lines of code for this. Okay, as a matter of fact, you can also get rid of this part. So input.get button, when it evaluates to true, it would run this code. Okay, it's an easier way to type it up. I just broke it down so you guys have total understanding of what's going on. So I'm going to go ahead and get rid of this line of code because obviously I don't need that. Hopefully you guys can have a better understanding of how, or at least have an idea of how you can do the left movement. I'm going to do that now. So there are 2 ways to do that. I'm going to demonstrate both. So I'm going to start with if input.get button round brackets and left. Okay, go to line, next line, have the curly braces. The thing is, the first incomplete thing would be I haven't defined the left virtual key. So let's go ahead and do that first. I'm going to go back to my Unity, edit and project settings, and under input manager, I'm going to make the size of the axes to 20 now. Okay, that would automatically create another key. Okay, so now you can see I have 2 writes. It basically creates a key using the very last key's name. So we have the last key as right, so it creates another one with the right name. I'm going to change the name to left, and the virtual button, not the virtual, the actual key buttons would be for me left arrow, so just left, and alt button, the alternative positive button would be A. You can see how the negative buttons may relate. So in an axis, it doesn't really return true or false. It returns a value from 1 all the way to -1, giving you an easier way to move your characters. Okay, with 1 line of code. Anyway, so with that done, I'm just going to go back to my code. So if left button is pressed, it's still the same code. So transform.Translate vector 3.left. Okay, because we want to go in the left direction. Not times time.deltaTime, time speed. This is a really naive approach of doing the movement, and the reason I'm doing it in this fashion is because I want you guys to understand every single line of code rather than just copying the code. Okay. I typically you're not repeating one line of code 4 or 5 times, rather than you're just creating a variable that changes the value. Okay. But still, it's important for you guys. You're starting out, just wanting to know how it's done and what's going on. So if I save my work and go back to Unity now, you'll have the right movement and the left movement. Okay, you can speed the movement up as you get play testing. Okay, it's faster movement. All right. Now, as I said, there are 2 ways to do it. So you can use if and if. I'm just going to quickly point out the thing that we can do with this. So you can, with right now, you can kind of press other keys as you're pressing the if button. You know what? It's not that noticeable or evident using right and left. I'm gonna do an up, which would give you guys a better way of understanding. So if I do if input.get button, I'm gonna do an up now. Okay, transform.Translate vector 3 dot up, again Time.deltaTime time speed, and also I'm going to do the input.get button. I'm going to do it down, so transform.Translate. This is going to be vector 3 dot down. So you can see how you could have just easily used one calculation where it changes the value rather than typing up the transform or translate every single time. Anyways, let's go back to Unity. I'm going to save this. Unity, I'm going to add the virtual buttons. So edit project settings. I'm going to make it 22. So I have 2 new buttons. One of them would be up. So virtual up button. It would map to my keys up, keyboard's up arrow, and my W key. And the last one would be called down. It would map to the down arrow and the S key. Okay. Now you'll see how with all the ifs, you can kind of move diagonally. Okay, like that. Okay, so if you're moving right and then you're moving left, both of them gets called, okay, like that. If you are making a game like this, which I am not, okay, I'm doing the game that I showed you guys, the Ghost Island, I didn't go for this effect, okay? So this is what you can do. Another way, or the way that my game is done and the effect that I'm going for is this. So if you have the right key pressed, okay, and then you can either move left. How long has this video been going for? We're going for long enough actually. I should actually try to wrap it up. It's not that. Okay, so the effect that I was going for is that you can only move in one particular direction. You can achieve that by making one of these blocks run at a time. So at the moment, if you press the right key, you move right, and also you have the ability to move left as well, move up as well, and down. Okay, so you have the ability to activate these sort of blocks as well. What you can do is just make them else if. It's another sort of conditional, which allows you to not have the ability to run all the blocks simultaneously, because you may have you may have scenarios where, not in this one, but may have scenarios where all the if blocks are working. Okay, so if you don't want that, if you want only one particular block of if block to work, just make them as else if. So you start off, the very first block should be if, and after that you just make them else if, else if, else if. Okay, the difference, if I save my work and go to my Unity, which is taking forever. There you go. If I launch now, you'd see how my player can move right. Obviously it can move right, but now if I'm pressing the up key, it's not gonna do the diagonal, so it's gonna only move up, down, right, left. It's not doing the diagonal movement, which I don't want, in my game, the design that I chose, that is kind of not I wanted. Also, because I wanted you guys to like have a good introduction to else if as well. Okay, so you have if, and you can use other ifs as well. But in scenarios where you don't, you just use else if. Okay. There are scenarios, as we are talking about conditionals. I just like to wrap it up with the else block. So else block works when none of these, none of the blocks above work. Okay, so if none of the conditions are true, whatever you have inside the else block would work. We are not in need for an else block because the movement script is kind of completed. However, just for the fun of it, I'm gonna do transform.Translate. I don't know, vector 3 up Time.delta. I'm not gonna use delta. Just for the fun of it. I'm just gonna do random dot range. So 10 minus 10 to 10. I don't know what it's gonna do. It's just gonna go randomly up or down. Okay, it's just for the fun of it. You don't need to do an else block. I'm gonna delete that for myself as well. Okay, I'm just showing you guys that whenever you're not pressing a key, that is when none of the if blocks. Oh, that disappeared. Okay, what I'm gonna pause my game first and then launch so I can please see my player disappearing. Well, it was too fast. Anyway, so the point is, can I bring this back up here? Point is, if I launch, it just goes away. And I saw it coming down. You know what, just to make it a bit visible, I'm gonna multiply it by time.delta.time after all. Time.delta.time. Okay, so if I go back to Unity and launch, okay, so if I launch, you'd see how the else block is working whenever you are not pressing a key. But the moment I press a key, all the if blocks start, not all of them, but like that part of the code starts working because one of the conditions is true, and then you can have movement. Okay, otherwise it just does that for fun's sake. So we don't need the else block. I'm gonna get rid of the else block. Okay. So yeah, so this is basically what conditions are. You have if, else if, else if, else if, and then else. You can have as many else ifs you want, and then if you're in need for an else block, you can add an else block at the end. Otherwise, you don't. Also, we saw how you can use if and if you are going for that sort of effect. The next part, we're just going to talk about how we can create our own methods. So update is a built-in custom event, built-in event. We're gonna make our own method and just tidy up our script a bit more. And also we will start on the baddies. All right. I'll see you guys in the next part. Bye bye.